close reading part where we have to read the passage and then answer the questions that follow. Part A to this question asks us to state the name of the two products formed when DEF is heated in the exhaust system. So we want to skim and scan, and we can see that in the third paragraph it says when DEF is heated in the exhaust system, urea reacts with water to make. Now, to remember, to make is to produce, so that's going to be our products, ammonia and carbon dioxide. Calculate the mass of urea in kilograms used to make 5 kilograms of DEF. So I want to skim and scan for information which tells us about the mass of urea. In the second sentence, we can see that it says DEF is a solution that consists of urea and water only. 32.5% of the mass of this solution is urea. So this is where we're going to be working with percentages and mass. So 100% is equal to 5 kilograms. We know that we need to scale for 32.5, same unit, same side. And then we cross multiply. 5 times 32.5 divided by 100 would give us 1.625 kilograms. Part C asks us to circle the words to complete the sentence. And in the sentence it talks about harmful gases in the exhaust fumes. In that third paragraph, it says that ammonia then reacts with two of the harmful gases in the exhaust fumes, nitrogen monoxide and nitrogen dioxide. Now, what we have to know is that non-metal oxides dissolve in water to form acidic solutions. So when we have this, it will form a solution which contains more hydrogen ions than hydroxide ions. Part D, state a reason why DEF is not considered a dangerous substance. So in that last paragraph, it says DEF is preferred to solutions of ammonia because it's not considered a dangerous chemical, and it's given us a few different options there that we can write as our answer, either that it's not toxic or that it's not flammable, and those are the two potential answers that we have. Part 2 to this asks us to calculate the percentage by mass of nitrogen in diammonium hydrogen phosphate, and the formula is given for us. So what we have to do firstly is to work out the GFM, and this will give us 1 mark. So if we look at the nitrogen, we've got 1 inside the bracket multiplied by the number outside the bracket, which is 2, times by the relative atomic mass, which is 14, which will give us 28. Hydrogen, we've got 4 inside the bracket multiplied by 2 outside the bracket, times by the relative atomic mass, which is 1, which will give us a total of 8. The hydrogen outside the bracket, we've got 1 of those times by the relative atomic mass, which is 1, which will give us 1. Phosphorus, we have 1 of those times by the relative atomic mass, which is 31. 1 times 31 is 31. And oxygen, we've got 4 of those times by the relative atomic mass of 16, which would give us 64. And therefore the GFM would come out at 132 grams. So for percentage composition, we want to put the mass of the element that we're interested in over the GFM. So that will be 28 over 132 times by 100, and the final percentage will come out at 21.21%. Written 4. Haloalkanes are alkane molecules in which one or more hydrogen atoms have been replaced by an atom of a group 7 element. Haloalkanes are produced by the reaction of an alkene with a hydrogen halide, such as hydrogen bromide. Name the type of chemical reaction taking place when ethene reacts with hydrogen bromide. What we need to know is that alkenes have carbon-to-carbon double bonds, which allow them to undergo addition reactions. Part 2 asks us to draw a diagram showing all outer electrons for a molecule of hydrogen bromide. So the formula is given as HBr. We want to do our group and our valency. Now we can't circle the highest valency, but we'll look at the one which is in the furthest group, which would be bromine. The electron arrangement for that is 2, 8, 18, 7. We circle the outermost occupied electron, and we can see that it's found in the 4th energy level, so we're going to draw a petal. It's got 7 outer electrons, so we pop them in. Hydrogen has the electron arrangement 1. Hydrogen is represented by a circle. We need to make sure that we overlap that so that the electrons can be shared. And this is how we draw a covalent sharing diagram for hydrogen bromide, and we can see in the overlap that we have our covalent bond. Written 4A part 3, name the chemical that can be reacted with ethene to make chloroethane. So if I draw out the full molecular structure for ethene and for chloroethane, what I can see is in the ethene, I've got a carbon to carbon double bond, and that has been broken, and I have added across the carbon to carbon double bond HCl, which is hydrogen chloride. 4B part 1, haloalkanes can be used to produce carboxylic acids in a two-step process, and they are given as a mechanism there. The question asks us to draw the structure of the haloalkane in step 1 that would react in this way to produce ethanoic acid. So they're asking us to work backwards. So if we start from the example given, we can see that propanoic acid has the functional group C double bond OH, which is our carboxyl group, and our ethanoic acid also has that. What we can see is on the left hand side, which is not in the box, that tells us how many carbon atoms our original structure has. So all we do is replace the C double bond OH with a bromine. So that will give us the structure here of bromomethane. A dilute solution of ethanoic acid is often used in food and household cleaning products. State the name given to a dilute solution of ethanoic acid. So this is learned from the course specification. We need to know that vinegar is a solution of ethanoic acid.